Okay, in this video, we are going to learn the multiplication property of radicals and how it helps us simplify radicals as well as multiply them. So this is what it states. Basically, it says that if you're multiplying two radicals together, that you are allowed, here's one, here's another, that you are allowed to multiply them together as though they're both underneath the radical sign. And in addition, you can turn right around and take a number that has more than two factors and break it apart into two separate roots. Okay? Now, there's a caution when you're multiplying these irrational numbers. Remember, radicals are irrational numbers. So this little bit of business up here is a good rule of thumb. You can only multiply radicals times radicals, and you can only multiply rationals times rationals. So you see my little caution here. I have a rational number on the outside of the fraction of the radical sign, and I've got a radical underneath. You are not allowed to multiply across this radical sign. And you might ask yourself, well, wait a minute, Mrs. Heinzman, how come I can't? And I would ask you to think back to the beginning of the year when we were combining rational and irrational numbers, and you had to answer a question on a test that said, what happens when you add, subtract, multiply, or divide rational numbers and irrational numbers together? And the answer always is you get an irrational number. This right here is the reason why. You're allowed to multiply 2 times root 3 all you want, but this is as far as you can get with it. Okay? These two numbers are being multiplied, but you cannot combine them any more than that. And that's what that property of real numbers meant. That's what that rule is. So, let's take a look at the property in action. So the first one, we've got square root of 3 times the square root of 2. So that's the same thing as the square root of 3 times 2, which is the square root of 6. Or, to say it shorthand, you say root 6. Next one, I invite you to write these down and try them yourselves, or just take note. Here is the square root of 2 times the square root of 7, which is the same thing as the square root of 7 times 2, which equals the square root of 14. Moving down, here's an example that has a negative sign in it. So here's negative root 6 times root 5, and that gives us negative root 6 times 5 equals negative root 30. And then last but not least, here is an example of a distribution where the blue numbers are rational and the red numbers are roots. So you see that when we multiply 4 root 2 times 3, we're going to multiply the 3 and the 4, and there's nothing to multiply the root 2 by, so it's just going to chill out and hang there with the 12. And please recall, that's one big happy multiplication problem right now. So then we're going to do the same thing with the next term. So we're going to multiply 4 root 2 times 2 root 3. So the 4 gets multiplied by the 2, which equals 8. And then the root 2 gets multiplied by the root 3, which leaves you with root 6. And finally, to recall from the previous video, this is as simplified as you're going to get this expression, okay? Because you can only add radicals that have exactly the same radicand or base, okay? So, next concept. So how can we use this multiplication property to simplify radicals? Well, we like to write our radicals in simplest form, and that means that the radicand, this number right here, does not have perfect square factors, all right? So what is a perfect square? Let's talk about that for a moment. A perfect square is a radical that simplifies to an integer. In other words, it's any whole number squared, all right? 1 squared is 1. 1 is a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. 16 is a perfect square. That means if you took the square root of all of these numbers, the square root is an integer, right? The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So let's apply this to our radicals. You see we have root 2, root 3, and root 10. All of those radicals are already in simplest form. But what about root 8? We use the multiplication property in reverse to break apart a radicand into perfect square factors and radicals that are in their simplest form. So you see, I've written the 4 in green. That means that's a perfect square. So I'm breaking apart the 8 into these two pieces, okay? So the square root of 8 is equivalent to the square root of 4 times 2, which is equivalent to the square root of 4 times the square root of 2, and the square root of 4 is 2. So we now have 2 root 2. Now this is simplified, and I invite you to pause the video here and see if you can do these. And I hope that you have given it a try. So let's break these down, okay? 12, does 12 have a perfect square factor? It does, 4. So this, the square root of 12, is equivalent to the square root of 4 times 3, which is equivalent to the square root of 4 times the square root of 3, which is equivalent to 2 root 3. That's simple. That is simplest form. Next, let's take got to get this exactly right. Now let's take the square root of 27. So the square root of 27, you can break that down into 3 times 9, right? 9 is a perfect square. So this means that the square root of 27 is the same as the square root of 3 times 9, which is the same thing as root 3 times root 9, which is the same thing as 3 root 3. Standard practice is to write the rational number first and the radical second. Okay, just like you would write a term in a polynomial with the coefficient first and the variable second. So I invite you to finish with the 124 and see what you can do with that. And we will continue to practice these. If this is confusing for you, remember that's okay. Please feel free to watch this video as many times as you need to, and we're going to be practicing this for a while, for a long while, okay? So you have plenty of time to get it. Thank you for listening, and I'll see you in the next video.